Hello, welcome back to another mind-blowing video. Have you ever wondered what scientists do to unwind and relax after long hours of research? They might watch movies, listen to music, go for a run, fish, or just enjoy peaceful moments with their families. After all, scientists are human too, and they unwind like the rest of us. Sometimes they entertain themselves by jotting down hypotheses, concocting conspiracies, or dreaming up wild and ridiculous ideas to satisfy the imagination of their 1.3 kilogram brains packed with 86 billion neurons. These brainiac researchers, with their wrinkly gray matter, sometimes like to challenge themselves with bold and unusual scientific ideas, a form of entertainment that we, mere mortals, might find mind-boggling and mentally draining. During the time when the US was locked down under the COVID pandemic, a group of researchers from the University of Rochester, led by PhD candidate Peter Michalczyk, came up with the idea of building floating cities in space, using materials readily available in the solar system like asteroids. In the past, space exploration was entirely in the hands of governments. All activities were funded and controlled by state-managed organizations. However, things are gradually changing. In recent years, the private sector has become increasingly involved in space exploration. Billionaires are growing ever richer, and with vast financial resources unencumbered by strict government oversight, they have made rapid advancements. In July 2021, billionaire Jeff Bezos made his first flight into outer space. His aerospace manufacturing company, Blue Origin, has successfully launched 22 consecutive missions, including 3 emergency escape tests. SpaceX, founded by billionaire Elon Musk, has made notable progress in developing heavy and super heavy launch vehicles capable of being partially or fully reusable, significantly reducing the cost of sending humans and equipment into space. Aerospace companies like Blue Origin and SpaceX are pioneering efforts to provide space access to everyone, not just billionaires. On its homepage, Jeff Bezos' company states that its vision is a future where millions of people will live and work in space, harnessing the infinite resources of the cosmos while relocating harmful industries off Earth to preserve our planet's greenery. And to create that colorful sci-fi future, humanity needs places to build homes, skyscrapers, and structures for millions to live and work. According to Peter Michalczyk and his team, that future might lie within asteroids. In a wild theoretical study, published in the journal Frontiers in Astronomy and Space Sciences, the research team outlined a plan to create large cities on asteroids. Adam Frank, one of the researchers, mentioned that his team was inspired by a popular sci-fi idea, building large space cities, similar to those depicted in the American TV series The Expanse. However, the research team proposed a new solution. Instead of building a city on an asteroid, they wanted to use asteroids as the material to build a sort of megastructure. An asteroid is any celestial body orbiting the sun that isn't a planet, a natural satellite of a planet or a comet. Scientists have observed about 1 million asteroids in the solar system, mainly located in an asteroid belt between 186 million to 373 million miles from the sun between the orbits of Mars and Jupiter. This asteroid belt contains over 200 bodies with diameters greater than 50 miles, and hundreds of thousands of bodies with diameters greater than a mile. This is a plentiful supply of raw material for Peter Michalczyk and his colleagues' idea. The idea began during the days when New York was under lockdown to respond to COVID-19. As Peter Michalczyk and a group of students and colleagues were searching for solutions to build a structure called O'Neill cylinder. It is a space habitat designed by physicist Gerard O'Neill in 1972. They essentially consist of 2 counter-rotating cylinders connected at both ends. The cylindrical habitat would spin to simulate gravity on its inner surfaces. The rotation speed of the cylinder must be fast enough to mimic Earth's gravity, yet slow enough that the inhabitants don't get dizzy. When a cylinder spins fast enough, it experiences the gyroscopic effect. Simply put, the gyroscopic effect is the ability of a spinning object to maintain the orientation of its rotation axis. A stationary gyroscope would immediately tip over due to an imbalance in its center of mass. However, when spinning at high speed, it can balance on a very small point or even on a string. So spinning fast helps the gyroscope resist tipping or changing the direction of its rotation axis. O'Neill designed two counter-rotating cylinders connected at both ends through a central shaft system to cancel out the gyroscopic effect, making it easier to adjust the orientation of the cylindrical cities to generate sunlight effect. In the context where manned spacecraft have no idea when they will be able to leave the solar system, the idea of building mobile homes from materials mined from the moon and available asteroids is an incredibly reasonable alternative. These could serve as a transition in the journey to find a new planet capable of housing billions in the far future. While O'Neill's cylinders offer a perfect solution for the gravity problem, they create another issue, potentially even more severe. Transporting the construction materials required from Earth to space or extracting them from the moon to create a cylindrical city would be extremely difficult and expensive. To solve this problem, Peter's team is thinking of taking advantage of the floating mountains in space. Using rockets to push these flying rocks to construction sites is clearly much faster, cheaper, and more efficient than transporting them from Earth or the moon. However, asteroids have their own drawbacks. The research team pointed out that most asteroids are not solid enough to withstand the rotation speed needed to generate a fraction of Earth's gravity. In reality, most asteroids are not the massive solid rocks many imagine them to be. They are essentially a loose collection of rocks, sand, and dust held together by gravity. If subjected to rotation, they may appear solid, but as soon as they start spinning, the weak bonds immediately break, and the celestial body turns into a heap of rubble. This means that, to build space cities from asteroids, future engineers will need to learn how to handle a pile of space debris. They need to contain it somehow. Michalczyk's team proposed placing asteroids inside a rigid mesh bag made from ultra-light and highly durable nanocarbon fibers. Asteroids will be enclosed in carbon fiber mesh bags, and massive engines will spin the asteroids to simulate gravity. This process will undoubtedly cause them to break into millions of pieces. The fragments of the asteroid will be flung outwards, causing the nanocarbon fiber bag to expand. Once the bag is fully expanded, the strands woven from nanocarbon fibers, each just a few atoms thick, will stretch out to catch the debris. As the debris settles at the bottom of the bag, it will form a thick enough layer of rock to shield any inhabitants from outside radiation. The rotation of the entire structure will keep the debris in place while generating artificial gravity on the inner surface of the bag. Based on the research team's calculations, an asteroid with a diameter of about 1,000 feet, roughly the size of a few soccer fields, could expand into a cylindrical volume with a habitable area of about 22 square miles. That's almost the size of Manhattan, New York, with a population of nearly 1.7 million people, just to give you an idea. Frankly, the idea of living inside a megacity in outer space remains firmly within the realm of science fiction even at the end of the 21st century. However, the laws of physics and engineering entirely support Peter Michalczyk's team. In reality, all the technologies needed to build this megastructure, from engines powerful enough to spin the asteroids to the material for the bags used to contain 1,000 feet asteroids, are either already in practical use or at least being researched. The next generation of super heavy lift rockets is being developed by SpaceX, known as the Super Heavy Booster, designed to provide a thrust of up to 17 million pounds, nearly twice the most powerful launch system currently in NASA's inventory, the Space Launch System, SLS. Not only is it more powerful, but the Super Heavy Booster, if successfully commercialized, could revolutionize the aerospace industry with an estimated launch cost of over 100 tons of cargo into space at just $10 million. This is because the Super Heavy Booster is designed to return to Earth for multiple launches, saving hundreds of millions of dollars in manufacturing costs. Meanwhile, NASA's single-use Space Launch System costs $2.2 billion for a maximum payload of just 105 tons. As for the bag material, the research team believes that nanocarbon fibers have the tensile strength necessary to maintain the structural integrity of a large rotating cylinder containing debris from the asteroid. In case you're hearing this for the first time, nanocarbon fibers are nanotube structures made of carbon, consisting of graphene layers arranged in a cylindrical shape. Graphene is a special allotrope of carbon, essentially a two-dimensional sheet of carbon atoms arranged in a hexagonal lattice. Graphene only exists, and I emphasize, it only exists as a sheet of 1 atom thick, which is about 1/1,000,000th the thickness of a sheet of paper. Despite its unimaginably thin structure, graphene is the strongest material ever tested by humans. A graphene hammock measuring 10 square feet could support an 8.8-pound cat, but would weigh only as much as a cat's whisker, or 0.01% the weight of a paper sheet. With such superhero-like properties, graphene should have been a dream material. But the catch is, it's incredibly difficult to produce in large quantities. As of 2020, the price of a ton of graphene ranged from $67,000 to $200,000 depending on technology and production scale. Assuming the nanocarbon fiber bag encasing the space city is only 1 inch thick, it would still require 45,140,000 cubic feet of graphene. With graphene's density at around 2,270 kilograms per cubic meter, the amount of graphene needed for each space city would be approximately 1.4 million tons. That's a bag worth $87 billion, folks.
Really, nigga?
Of course, asteroid megacities won't be happening anytime soon. The necessary technologies still need time to mature. However, the idea of a massive artificial structure that could provide living and working environments for millions of people is far from ridiculous or far-fetched. Remember, in the year 1900, no one had ever flown in an airplane. Yet, at this very moment, as you watch this video, thousands of people are enjoying their moment tens of miles above the Earth at speeds nearing 1,000 miles per hour. And just like those prank videos with unexpected endings, never underestimate what technological advancements in the next 100 years can achieve. What do you think will be the best option for human civilization in outer space? Leave your thoughts in the comments. Remember to like and subscribe to Omnicessory for a weekly dose of mind-blowing content. Don't forget to hit the bell for the newest videos. Until next time, stay curious and goodbye.